Uh, Today we'll be solving on techniques of limit. Techniques of what? Limit. That is limit of functions. We are having limit of function today. So we will be applying the techniques of what? Of limit. The techniques of what? Of limit. So there are different techniques we apply in limit of a function. There are different what techniques we apply in limit of what? A function. The essence of these techniques is for some functions after solving them that does not what exist, that is they are undefined. For instance now, after I solve a question, a function, and I end up having 0/0, I should know that it is what? Undefined. Or infinity over infinity, it is what? Undefined. Or n over 0, it is also what? Undefined. So in some cases whereby I'm having these challenges, after I have what? I have solved the what? The function. I have solved the function. I end up having 0/0, infinity over infinity, n over 0, and I already know it is what? Undefined. I have to apply the techniques of what? Of what? Of limits. Techniques of what? Of limits. So these techniques are what? Are like 4 or 5 what? But today I'll be talking on just 2 of them. The first one is limits by factorization. Limits by factorization. The second one here, I'm talking about limits by rationalization. Rationalization. And we have the other ones divided by the highest power, the L'Hopital's rule, and so on and so forth. But today, I'll be applying just these 2 techniques. Here I'll be using this rationalization. It is the one, a function that has to do with a root. But this work like a let me say a quadratic function. A quadratic function having the power of 2 or 3 self, sometimes 3 or 2, but quadratic what? Function maybe. So the reason why we are using the techniques of what? Of this limit is for some cases, for some problems, whereby we are having 0/0 at our what? At our answer, or infinity over infinity at the end of our what? Solution, or n over 0 at the end of our what? Solution. All of these are regarded as what? Undefined. So we must find another way to what? To obtain our what? Our answer. So that method we apply are the what? Techniques of what? Of integral. Techniques of what? Of limit rather. Techniques of what? Of limit. So I'll be talking on these 2 today. So let's have some examples on this. Let's assume that we are given a question: x squared minus 4 all over x squared plus x minus 6, and we are told to limit this. Limit x to what? 2. We ask for limit x to 2. How do we solve the question? Now let me apply the direct method first. If I apply the direct method on this, I'm going to have 2 squared 4 minus what? 2 squared plus 2 minus 6, which will give me 4 minus 4 all over 4 plus 2 minus 6.
Wow.
0 over 0. That is what? Undefined. So I have to apply the techniques of limit here in order for me to be able to solve the question. So applying techniques, I have to factorize this using factorization. So here, since I'm given x squared minus 4 all over x squared plus x minus 6. All I need to do here is this. I can write this as x squared plus, minus 2 squared all over x squared. I can also factorize this. I will look for two values whereby when I multiply it, it will give me minus 6. And if I add that two numbers, it must give me what? Plus 1. Because this x is carrying what? Invisible 1. The two number is minus 3, 3 and the two numbers will be 3 and minus 2. So 3 times minus 2 will give me minus 6. 3 minus 2 will give me what? 1. Therefore, I can rewrite this x to be 3x minus 2x. 3x minus 2x is same thing as what? As x. So instead of me writing x, I will write as what? 3x minus 2x. So therefore, I'm having x squared plus 3x minus 2x minus 6. So put a bracket on it. So difference of 2 squared, that will be x minus 2, x plus 2 all over x is common here, x minus x plus, if I cancel x, I'm left with 3. Minus 2 is there, x what? Minus plus 3 rather, because this minus we cancel this minus. This minus we cancel this minus rather. Then 2 here, 2 is 6 is what? 3. So I'm left with x minus 2, bracket x plus 2. So this and this are the same thing. I'm going to write 1 out. Then write x minus 2 outside, x minus 2. Wow. This will cancel this. So I'm left with x plus 2 over x plus 3. So I can now what? Limit the function to what? 2. Whenever I see x, I'm going to put 2. 2 plus 2 all over 2 plus 3 equals to 4 over 5. So my answer becomes what? 4 over 5. I think my answer becomes 4 over 5. So this is my answer. This is my answer. So let's try another example so we can understand better. Let's try another example here. Another example. Let's assume that we are given x squared minus 4 all over 2x minus 4 is okay. 2x minus 4. We are told to limit x to 2 here. So then direct method, that will be 2 squared minus 4 over 2 brackets 2 minus what? 4. Which is as 4 minus 4 over 4 minus 4, which is 0 over, it is what? On the 5. So I'm going to apply techniques of integral here. That's what? Factorization. Limit by what? Limit by factorization. So how do I do this? The next I'm going to have here is, since I'm having x squared minus 4 all over 2x minus 4. So I'm going to what? Factorize the difference of 2 squared here, x squared minus 2 squared. Then 2 is common here, 2 open bracket x minus 2. So difference of 2 squared here, that will be x minus 2, x plus 2. So all over 2 brackets x minus 2. This will cancel this. X plus 2 all over 2. So I'll now limit x to 2. Whenever I say x, I'm going to put 2. That is 2 plus 2 all over 2, which is what? 4 over 2. 2 over 2 is what? 2. My answer becomes 2. So this is the answer. So in a cases whereby you are having problem, challenges on limit of function, whereby after you solve it, you're having 0 over 0, infinity over infinity, or n over what? Infinity. You don't need to stress yourself. Apply the techniques of what? Integral to solve it. So the techniques is either use factorization method, and the one involving the root, you have to do what? You have to rationalize. That is called rationalization what? Method, or divided by the highest power, L'Hopital's rule, and so on and so forth. So